Alright, another in a series of videos asking the question, why can't this be true in terms of a simpler model for what's happening in the universe in terms of explaining the basic functions of gravity and magnetism and blah 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 blah. So anyway, the standard model basically accounts for none of the energy in our universe, in the sense that Einstein's bent geometry doesn't explain where the energy comes from to push or pull. It just says it exists. There's a vacuum cleaner of sorts that's inside every atom that's pulling some ether stuff, sucking it up, and somehow everything's being dragged along. There's some mechanism, you have to argue, but there's no mechanism described by their theory. And so there's no energy involved in their theory of gravity. So they call it a weak force compared to magnetism, but clearly it's not so weak in that it's moving suns and galaxies and all kinds of big things all over the place in the universe. And I would argue that it breaks any notion of unifying the forces, in the sense that they don't have a consistent explanation. We know that everything else in the universe needs energy. I have to eat food. I have to take stuff that's hot and spread the heat into other things, so to speak. I have to take a force or energy or something, movement, and I have to move it somewhere to make something move. I have to change it. And nothing tells the something what to do. I mean, that's basically their theory of gravity. So that's the subject overall of this video, defending the fact that you have to account for the movement, you have to account for the energy, and once you do that, you have to deal with a theory that actually has energy in it. It's some understanding that energy is a something, not a nothing. It's more than just a event, that you don't have to account for. Also pointing out that quantum mechanics theory for magnetism and all the other action we see in the small universe is basically unaccountable also. They have a notion of some force carrier called a virtual photon that somehow creates pull or push or whatever, attraction and repulsion as needed. No mechanism for how it figures out as needed. How it knows how to do the different functions, how the different functions are in fact different. None of that's explained. They just explain the outcomes, which we all can observe. We have a mathematical theory that explains how much pressure there will be between two magnets. They do nothing to explain how that pressure is manifested. No explanations. It's all virtual mush. Nothing really. And their actual science is never appreciated by their scientists, in the sense that what's actually lines of force they confuse with the wrong lines. So they don't even get the fact that the basic mathematical model is a model of radiant force stuff moving in straight line vectors. That's what a virtual photon is, something that moves in straight line vectors. And they don't even pay attention to that. They think they're crossing some other kind of lines, when no, they don't even get the lines right. So their theory is so bad that they don't even understand it. And they certainly don't understand what the mathematics that they claim is so brilliant is derived from. What its basic element is, which is an angle of change in the vector of the force. Not something called a wave. Anyway, all these subjects end up related. So we start with here's your simpler model of what's in the universe. There's stuff called force, moving the speed of light. Little bits of momentum. I don't care whether you call them ether bits or... it doesn't matter. The point is they have constant momentum. So they're always moving the speed of light. They are energy, because you can't destroy them. You can't get rid of the momentum they have. And there's two flavors, just as there's two flavors of matter. Now, matter is like a boat in an ocean, and the little force bits are like rowers. And what's basically going on in our universe is rowers can jump out of the boat and jump into the boat. So there's rowers in the sea. That would be these free these free force bits in the universe, and that could be in the form of a photon, a visible photon, moving the speed of light. That would be these little fellas at a specific distance from each other. And they can be possessed as momentum in a piece of matter. That is, if an electron moves or a proton moves, it moves because one of these guys jumped in the boat and is now rowing. And when that happened, they gave back a rower in the opposite direction. So this guy, this little force bit, can go into this boat, and when he does, something going the opposite way leaves. So there's a net movement in this direction for the boat. And he can just stay in that boat until some other force, as Newton would say, acts on this electron. This electron doesn't change its speed until some rowers jump in and out of the boat. If nothing jumps in or out of their boat, they'll just keep going the way the rowers that are in the boat are going. It's only when something changes who's in that boat does that boat change its momentum. But all the momentum that these things have, they only have because they have elements of force, elements of those little bits inside of them. So that's what defines their momentum, is the force. They have no innate give a damn. These things are what gives them a give a damn. Now, this isn't entirely true. If you understand that you can have an uneven balance, so this electron could have 5 positions in its boat, and if it has 5 positions, oh, we can't see that, so we'll do it with this. We'll just do it in black. You don't need everything perfect, do you? No. You're intelligent people. You can get the gist of something. So if you have rowers in all directions, these seats in a geometry, you can sort of understand that if 3 of these rowers are going this way, rowing that way, and 2 are rowing the opposite way, that you'd have a net, okay, in this direction. And the electron has, I would argue, that disposition, that it always has a momentum, just because of the rowers in its boat. So it always wants to go in a direction, and a force has to act on it to stop it from moving in that direction and cause it to move in the other. So you could understand if another rower jumps in that's going this way, well, then this side now has 3 rowers, and this side only has 2 because it gave back one this way. So it would always have an imbalance. This stuff is what really is how the universe functions, and everything that happens because of this mechanism, this relationship between force and the momentum of these bits, of matter. And so even something like gravity, its origin is this, which is polarized. You can sort of understand this as a dipole here, and these would be monopoles if segregated, and that the function is going to be different if you're capable of feeling that difference. So let's understand the basic mechanism is the proton and the electron and the proton. The black bits would reflect off an electron. That is, the rowers would exchange, so it would go from 5 to 3, 3 to 2 to 2 to 3 in its disposition through that interaction. But if a red force hits it, it's a benign reaction. The force is just ejected in a perpendicular direction. And the same is true for the electron with the red force. Well, the proton reflects the red force, gains momentum, and it ejects the black force. And through that mechanism you can explain magnetism and everything that happens in the universe quite well, quite completely, relatively completely, certainly compared to the standard explanation of conventional physics. Alright, so the history of particle gravity, or just the subject of gravity, through history, there's always sort of been a conflict, I suppose, between people who believe there has to be a push or there has to be a pull, or people who believe that that the kernel there has to be something, a force, that has to be acting on something. There's just nothing, clearly people argue that attraction is just some kind of magic. It feels the attraction, the space bends, and it just falls into the bent space or some kind of crap like that. So there's these two models in the past, and they were argued through Newton's time, and people would vacillate on their explanations. Newton basically made the statement that there has to be some mechanism, it can't be nothing. And then Einstein came along and provided a nothing explanation in the sense that there's no force, and he got away with it. If Newton had suggested the nothing tells the something what to do, he probably would have been laughed out of his exalted position. But times change, and people will start buying anything when they get desperate, I guess. So they couldn't figure out this right answer, so they had to make a wrong answer right, because they were sick of being wrong. Something like that. So anyway, so the particle model started 350 years ago or whatever. Different people gravitated to it. This guy called Fadio, I think, was really the originator of it, as a thought. And maybe other people came to the same conclusion on their own. De Cinti and different people are apparently were advocates of a model of momentum from the external universe in the form of some kind of real force. And I came to that conclusion independently. I never heard of Lesage before I thought of the idea of turning photons into gravity. Photons we couldn't see. The electromagnetic spectrum that's not visible, so to speak. And so this is a very old idea of understanding just a simple kind of concept that you have two objects, and if there was pressure coming from the external world always hitting these objects, that the end result of that would be that these two things will move into each other, because they'll create a kind of shadow. This one will shadow this force, this one will shadow this force, in the sense that this force won't get here, because it's a straight line. This little stuff moves in straight lines, it doesn't curve around things. So this force doesn't get where it's going, doesn't hit this guy. And so now you have an imbalance. You have more force on this side than you have on this side, so this thing has to move this way. And likewise, the same thing's happening in inverse. Now this creates complications where you're going to explain that there really can't be a absence of force, but that's what you're basically arguing, is that the force is now trapped inside of the object. It's inside of these things, okay, in the form of motion inside the object. So there's motion now where this force isn't gone from the universe, it's just in here, not going there. So it's stuck inside of something. It hasn't been destroyed, it's just been turned into heat. Okay. And heat, close enough. And so what we call heat, and heat is motion. Heat's pressure. Those two things will cause heat. You move two things closer together in any kind of circumstance, and you're basically creating heat, because you're going to create more of these reactions. Because the reaction time, you can sort of understand, if I move two things together and they're reflecting force between them, the force is hitting them and it's reflecting, and so there's force they're admitting, because they're getting hit by force, they're admitting force. And it's sort of an equalization, thermal equilibrium, you could almost argue. But regardless, you could understand that, proximity is going to dictate how much they're going to feel this energy, this distance. If you change this distance, you're going to multiply the number of times this interaction of reflection takes place. And that's basically heat, because this all equals, each impact equals an impetus to move in a direction. So it's not the pen, it's this board. It sucks. Yeah. I don't know what I'm supposed to do about that. I mean, I cleaned it. It's just some colors work and some do not. But I don't know what it is exactly. Well, anyway, I'll worry about that in some future date. Alright, so to the gravity argument. So Lesage first came up with a model. It just called them ultramundane particles. That basically would have been this force stuff in the forms that we can't see. And let's understand that we didn't discover that there was a cosmic background radiation until relatively recently, you know, the 19th century, the 20th century. I would say right now that, you know, science is kind of clueless about some stuff, but let's understand that it took Hertz 7 years to create a device that could even see the photons that aren't visible photons, the radio waves, and the cosmic radiation, the rest of it. So all that was discovered. You know, even X-rays weren't discovered until Tesla's time. You know, again, 20th century discovery. So there's forms of energy that clearly weren't obvious, and I would argue that there's still a form of energy that's not obvious, in the sense that we don't have a great detector beyond watching things fall in gravity. But gravity's there, just like light or anything else. It's a real force pushing on things, hitting them and exchanging momentum, just like the electromagnetic spectrum does. Little bits of X-rays will hit an atom and they'll move it, causing heat, and they might even break the atom because they'll force electrons to pop out of the, force the electron to get an imbalance in its momentum and pop out of the atom, break the atom. So we know this force is the mover, and the argument is there's more of it than you think, or that conventional physics is acknowledging might exist, and instead of bent space and virtual photons, force in this form exists that we haven't accounted for. So we account for this stuff at a frequency because we have detectors for that. But if I make this thing small enough, this ray, we won't detect it. Our eyes can't see a ray unless it's 6 quanta large. It has to have 6 quanta in it before we can see it. Well, what if it has 3? Yeah, we wouldn't be able to see it. We wouldn't know it was there. So lots of energy can be in the universe without a frequency, in small chunks in frequency, and we don't have any detector besides watching it move. And that's what we see in gravity. We see the things move. We see them being pushed by a force. We even call it the force of gravity, even though they don't identify what a force is. Alright. So the modern view, just as Darwin's evolution was improved by Gould's deduction that there's a ton of evidence indicating that evolution happens in small groups of colonies of DNA, not in large groups of DNA. That's the basic, simple argument. That in large groups the DNA gets diluted. In small groups the mutants have a much higher rate of success than in a large, dense population. So if you're a freak of nature, you'll do a lot better if you're in a small family than if you're in a big, giant society, in terms of your DNA getting to the future. Simple argument, but it's an enhancement of the theory of evolution, and certainly explains why the evolutionary record of the geology, what's frozen in the geology, doesn't provide a perfect, it has missing links in it. Well, it has missing links because most of the evolution happens in small groups, not large groups. So anyway, and you're not very likely to get fossilized. Very few win that lottery. Okay. I'm hoping to in some form or another, but it's just a hope. Anyway, all right. So Lesage's crude understanding of the shadow idea is simple and it's easy, but yeah, it leaves some gaps. It leaves some things unexplained, and you have to explain those things. So one of the things that Bill Gates has pointed out about this problem with this idea of, I mean, this just sucks. Pressing harder doesn't work. I mean, it just sucks. You know, I can't draw with a damn pen. And I clean the thing with alcohol and it still doesn't work. Look at that. Nothing. See if this stupid one works. Shit. This shouldn't be complicated, right? On a whiteboard, what's the big deal? Yeah, it's a piece of shit. Alright, I'll pause and see. Maybe I'll try some other... Let's try something else. Try something cleaner. This fucking stupid piece of shit. This is stuff that should work. Really should work. Alright, back. See if it works now. Tried vinegar. Anyway, so Bill Gates sort of pointed out that this model of two objects and the idea of a low pressure between them, you have to account for where the pressure went. You can't just say, oh, there's high pressure out here. Okay. Well, high pressure out here. And low pressure in here without accounting for where the pressure goes. And so, because the idea would be is that you would reach a thermal equilibrium in terms of the amount of energy being created inside the object that's being stored in here. There's sort of a limit, but there really isn't, because you can sort of figure out that as each one of these objects get bigger, they get hotter and hotter and hotter. So as something gets bigger, I guess I could use color to indicate, this is going to create more internal pressure. Because everything, when something's growing in size, you know, a material object, what's really happening is all the little bits are being pushed into the thing, and you're changing that proximity thing. You're forcing matter to get closer and closer. And as pointed out, when these things get closer to each other, the reflexive energy, the rebound energy, gets higher and higher. As I bring the ping pong paddles closer to each other, they put their ball between them, it's going to bounce much faster, and each bounce is a momentum exchange. And you can understand all the bounces are going that way or that way, so the momentum has to be a push from the inside when something's trapped between them. So again, it's not as simple as just casting a shadow. And so this heat represents basically the consequence of the extra pressure. So as you make things something bigger, you can understand that the deeper you go in the ocean, the more pressure there is, and it'll pop your eardrums and, you know, crush you. If I put you deep enough, I'll crush you. Actually, you'll actually be crushed. You know, just a fact. All the air will be pushed out of you, and all the any spaces you have, so to speak, that are of any kind of insufficient pressure will be pressurized to the full pressure of the environment you're in. So you can understand that when things start getting big, they start getting hotter and hotter and hotter and hotter, just because of the amount of pressure. And the pressure is basically, you know, this stuff inside is just going, one piece is going one way, another piece is going another way. One piece is going, you know, and it ends up being swirly in the end. You know, everything starts swirling around. But the basic idea is there's stuff going this way and there's stuff going this way. Lots of activity in the sense of lots of stuff being pushed constantly making these exchanges of momentum. So that's why the sun's essentially on fire. It's because it's sufficiently dense that the pressure is crushing the atoms. It's breaking these electron and proton relationships in atoms. The big atoms are being just crushed to pieces. And so they sort of argue how suns are, you know, when they supernova, they're creating those big elements, but they're consuming them also. You know, if you put a piece of gold on the surface of the sun, the likelihood is it's not going to be gold very long. But anyway, won't get in, you know, that's another argument. It doesn't need to be made in this video, certainly. So the point is when there's only a few atoms, not very hot, more and more atoms, more and more heat, because more and more pressure, because the atoms are in fact still being accelerated towards the center. So every big object, every atom on it, that is you included, your atoms, are still moving. Even though they don't look like they're moving, they're moving. They have acceleration, so they're continued to accelerate. And what happens is they're pushed back. So basically you move into the earth, you dent it a little, you dent your chair, and the earth fights back and pushes back. You only dent your chair so much, and then you create a bunch of pressure on the chair, and it pushes back. And that's what's, so you're not really sitting on the earth or standing on the earth, you're bouncing on the earth. And that gets to the whole relativity argument and how this is a much bigger distance. And that's why your metabolism has been slowed down, is because you're traveling a lot of distance up and down when you're on the earth. You're not just moving this way, around the circumference as it's spinning. You're moving up and down the whole time. And the satellite out here is moving much slower because there's less gravity. So it's going less distance. Even though it's going faster this way, it's going less distance this way. And you're going slower this way, but much more distance this way. And you're actually traveling faster than the satellite, going 22,000 miles an hour. Well, you're going faster because you're on the surface of the earth and you're doing this thing a lot more. But anyway, so that's a different, it just points out how this all ties together. One thing explains the other things. So anyway, so this heat thing is really how you're storing the energy of gravity. So you could make the simple argument that a planet that has moons, that those moons are basically tied, and that they're going to cause lots of agitation if they have motion. They have to have motion or they'd fall in. So their velocity will be exchanged for a velocity on the surfaces and inside the object, and create even more heat. So more moons, more heat. And the heat is basically a representation of the fact that more energy went in this way than energy came out this way. So there is no thermal equilibrium in the sense that you have to count the heat that's stored inside the object as part of the real force accounting. So a certain amount of energy does come in from the outside, and somewhat less energy was given back to the universe as a fact. And the fact that it's hot means that it's trying to push its way back out to the universe, but it's just not getting there because it's doing this circular thing. It's just going around in circles. The molten crap inside the center of the earth is going around in circles, no doubt. The heat, because it's not getting out. Okay, that's what all this idea of turns is. You can only make so many turns, and you're going to get out of something. If you just keep making right turns, I can't do it over there. If you keep making right turns, you're not going to get anywhere. You're just going to end up in a circle. And that's basically the problem the heat has, is the heat is in the center going out because the pressure is being applied towards the center. This stuff is pushing down, this stuff is pushing up, and this is where the pressure is the highest. Even though you could argue there's no gravity in that space. If I could dig that out, I'd have to build a huge pressure wall to dig it out, right? I couldn't have an empty spot inside the center of the earth without making some kind of incredibly strong surface to push back the pressure. But if I could, then there would be no gravity in there. Because there's no gravitational pressure in there, there's just the matter having momentum pushing. So this is all electrons and protons pushing, pushing, pushing. Because they're the things that have been given the momentum from the free energy in the external universe. Alright, so I think that's enough of that. And so let's just go through the simple, back to the shadow argument, but it is really that simple what's taking place with gravity. So you can understand that if I have an object, a pre-existing object like the Earth, it's making gravity right now. Okay, I don't need to show up to say, make gravity, okay, because right now, all right, it's collected a bunch of objects, a bunch of matter. it's collected it, and it's collected matter, obviously, that has to be moving into it. So all this matter it collected had motion towards its center. That's the only way you could possibly collect the matter, right? So that momentum, you could say, is stored inside of this object. So all of this stuff, when it was first acquired, there was an initial movement in, okay? And now it's going to be in a trap. So now it'll trap, okay? And so now the energy is trapped. But you always have to account for that initial bit in. See, the trap doesn't mean that you undid its initial momentum. Okay, so when something goes into a trap, the trap is a separate unit. And you still have this left over, so to speak. This, okay, will account for this, and this will undo this. So you can understand that those things balance out, but you never undid this. So the momentum going in is still there, just like you're accelerating right now towards the center of the earth. You're being pushed. And that's a real event. And that real event is this. And you can't undo it even if I trap this piece of energy. That is, I don't let it go the speed of light over here. I keep it in some trap. That's heat. Okay? Understand, that's heat. That's heat when you have an object that's hot. That's basically what's happening. The heat can't get out. It's trapped. And the trapping of the heat, okay, is basically movement of these electrons and protons. And that's creating a pressure between objects. So anyway, so it doesn't, so you always have to remember that this initial bit you can't undo. So all of this stuff has this first bit of motion. So yes, once it gets in here, it's going to do this circular thing. But this still exists as the initial piece of energy. So it still has something to absorb. So there's no such thing as equilibrium in that sense, that you can't just undo what it is. It's still moving, even though it's trapped and circular, it's still moving. It's still a real force. It's just that it's acting on things in both directions, so you don't see it as a force. But it's still a force, and it's still in the object. So every bit of matter, the momentum of that piece of matter, still inside the earth, meaning that force didn't get somewhere else. Okay, it didn't go back out. So the thermal equilibrium can never undo the fact that it's going to consume. This part is still getting trapped with each piece of matter. Each piece of matter adds to the pressure in here. It adds to the heat. So you can understand that if this was a heat storage device, and you thought about, as you store heat, you're changing this equilibrium. So stuff goes in and stuff doesn't come out. It stays in as heat. And every atom makes this thing hotter. So every atom that hits the earth, every atom that created the earth, is now stored. The energy of those atoms is stored as heat. It's still in there. It never went back out. Okay, never got free. So anyway, so that's why there's still a deficit. And the earth is basically a negative force engine, in the sense that it's always taking in a little more than it's giving back, in the sense that every bit of motion of the atoms, okay, is still in there. Not every bit of motion, that's the wrong way to say it. For every atom that was moving, there's an increase in the pressure and an increase in the heat. So again, the atoms are still in motion. So you have to think of a standing object as really not being a standing object. We're not a thing. We're a bunch of little electrons and protons that are still moving. And they're moving yeah, they're moving. All right. It's not complicated, but it just requires you to understand that there's no thermal equilibrium doesn't mean that you don't have imbalance in the sense that you've absorbed more than the universe is bringing in at any one point. Yeah, because the atoms are real. Anyway, so the argument is for particle gravity, a simple argument is. Now this is all happening on this magnetic charge way, in the sense that it's all red and black stuff, but you can sort of understand that the electrons dissipate proton energy, the protons dissipate electron energy, and all that would equal out. So if you don't have a magnet to test the magnetism, then all you detect is the gravity. In the sense that it's just your so just to understand it, it's all happening with both of these forces. So the universe, the external pressure is red and black. All right, it's not just black energy, it's red and black, but these two objects aren't going to polarize, they're not going to segregate it, they're not magnets in a significant way, so they're not going to change they're not going to be redder at one end and bluer or blacker at the other end and all that kind of stuff in any significant way. Like I said, a little bit happens, there's a little bit of a magnetic field, but not much. So even though the interactions are going to be more complicated than just energy coming in, it's two forms of energy, that difference isn't going to make any difference, because the two things, the electron and the proton, are doing opposite things that balance out in the end. So the idea is that you have this external pressure that would be just like the cosmic background radiation, it's just in a form that we don't see, gravity. It's little bits of energy that we don't have a detector for except to watch things be moved in it. And the two objects do is, like I said, you can understand, each one of the atoms is absorbing momentum, and everything's pushed towards the middle. A percentage of it's trapped as heat, and you end up with energy that doesn't get. Energy moving this way, the speed of light, gets trapped, doesn't get to another surface, and because there's more pressure out here than there is pressure in here, this object moves, and when it moves, it's absorbed this piece of energy, right? So when this object moves towards the other object, that means it absorbed a rower, and it gave back one going the opposite way, and so it moved the whole giant object this way. But to move it this way by gravity, once you've done that, once you allow gravity to move something, the other object is going to fight back, in a sense that now you absorbed a piece of energy going this way, the speed of light, trapped it, and so now it's not going to get hit with it here, and so now it's going to end up moving this way, because it's going to have more rowers jumping in the boat this way than rowers jumping in the boat this way. The balance is going to be clear, and the electrons inside of it are going to move, and that means the protons will move, and that means the atoms will move, and the object will move in this direction. When it does that, reciprocal happens, and that's basically how gravity functions. But the initial gravity that moves you into gravity, already exists, because there's already this net imbalance because of the fact that the thermodynamics is happening every second, and every second that anything goes in, it's creating momentum and absorption. I've also pointed out that the energy goes in as another way you can understand the thermodynamic thing is that energy in the form of gravity is force. So it's just the speed of light stuff in little discrete bits. And the way the energy leaves, can be in much bigger pieces. Electrons moving off the Earth, other pieces of heat. So the force goes in dense and spread evenly, and it leaves in clumps, bumps of energy going in individual vectors. So it's not spread out anymore. So you could clearly understand that it's like having 1,000 soldiers in a truck and the truck goes a direction into a field of soldiers coming, well, it's only going to hit, the small 2 soldiers here. So you wasted 1,000 soldiers to wipe out 2, and all these other soldiers got right through because you didn't spread your 1,000 soldiers this way. So when you condense the energy into matter moving, then there's clearly not going to be an even exchange between the force. So the forces are coming in, like this, and this is what you're calling balance, is that you have the same number on each side. But the point is what you're doing is you're consolidating all these, okay, into one big one. And he might wipe out these 2. And he'll go further because those 2 won't wipe him out. But this energy is still going to get through. And that's why objects have gravity even when some other object isn't. That's why it's always a deficit that you can fall into. Yeah, I think that covers that. Yeah, I think that's enough to explain. It's just about pressure, so you're creating, again, it's just about speed and trapping the speed. So it's just traps. It's just so easy to understand. If you have a force traveling somewhere, all right, and you cause it to do this, just to get caught going in a circle. Obviously this circle can be very elaborate. Inside of the Earth, there's little pieces of heat just bouncing off the outside. They're bouncing. They can never get very far. They can't get to the surface of the Earth. They just keep hitting stuff before they get there, and that's essentially an insulator. How heat has to get through a substance, and it just never gets through it. It's too likely to get reflected back. It just keeps reflecting back and forth, back and forth, back and forth, back and forth, back and forth. You can just understand that that's how it's stuck. It's trapped. So you're taking stuff, energy, that was moving in a direction, you're trapping it. It means it's just not going to get where it was going. This just ain't going to be there. So what was ever over here ain't going to get hit by it. You can just, it's obvious. So as long as this is straight line force, you can understand that there's going to be places that are going to be shielded from force when 2 objects are in proximity. The force just can't get to them. And there's a consequence for it. The consequence of that is that there's going to be more pressure on the other side because it's not going to be balanced anymore. And obviously the starting position is that the universe is balanced. There's as much stuff hitting you from one side as the other. But even if there wasn't, we couldn't tell because the whole universe would be moving in a direction. And we wouldn't be able to see it relatively. Not relativity. Anyway. Okay, that's enough now. So at least I found vinegar works adequately. So I got something out of the video. So anyway, so that's, it could have been better. I just hadn't got the new talking points explaining how the Earth's thermodynamics is basically the idea that it's changing force, free force in the universe, stuff moving the speed of light, into atoms or electrons and protons moving. And that's what the Earth ejects mostly in terms of what it's radiating back to the universe is those clumps. And those clumps are really ineffective in compensating for the density of the force that is gravity. And so there's an imbalance created, and that's why you fall into gravity. You're falling into that imbalance. All right. Yeah. So that's enough of the video. So till the next edition of, looking for somebody who wishes to defend conventional physics. So the standard model, bent space, virtual photons as explanation. Somebody who wishes to defend what is, talked about as if it's the most brilliant explanation that mankind ever came up with, and it's you want to defend the strength of the evidence for gravitational lensing, or the strength of the evidence for whatever bent space is, or the strength of the evidence that that even the virtual photon is a rational explanation. You want to demonstrate through some sort of, show me the Maxwell drawings that have waves in them, please. If you're going to say Maxwell's mathematics is wave mathematics, then why don't you show me one of his drawings that has a wave in it? Somebody wishes to defend this, what I'm just plainly calling just a garbage theory. It's just so frickin' incomplete, unevidenced, and silly. It's silly, unevidenced, and it doesn't even answer any of the important questions. Why do people believe it? It's garbage as a theory. It's crap. Does somebody wish to defend it? In a conversation where I can, interrogate you, you can interrogate me on your knowledge of the experiments and what they actually demonstrate. All right. Come on, somebody man up, please. You can contact me at ds@draftphysics.com. It's right in the description of the video, for fuck's sake. But anyway, till next time. I'm clearly saying I'm right and you're wrong, and that doesn't make you wish to defend your wrongness. Prove to me, show me to be an idiot. Come on, do it. Come on.